Welcome students. Myself GB Patel, lecturer in Mechanical Department, VPMP Polytechnic. The subject is Fluid Mechanics and Hydraulic Machine. The subject code is 3331903. Today we are going to discuss the Darcy's Weisbach equation. The objective of this video is to derive the Darcy's Weisbach equation. So let us derive the Darcy's Weisbach equation. Consider one pipe, flow through pipe. Here the direction of fluid is from left to right, as you can see in the figure. So the direction of friction force in between fluid and perimeter of this pipe is opposite to direction of fluid flow, which is from right to left. Here F is a frictional resistance force. We consider two cross section area on the pipe. This is cross section area 1,1. This is cross section area 2,2. The distance between section 1,1 and section 2,2 is capital L. The force exerted on cross section area 1,1 is capital F1, and this force is exerted due to this pressure P1 on cross section area 1,1. The force exerted F2 on cross section area 2,2 is due to this pressure intensity P2. Okay. HF is head loss in between cross section 1,1 and cross section 2,2. P is a weighted perimeter. Here the flow is fully developed. So the weighted perimeter is pi into d. Small d is the diameter of pipe. The cross section area, you can see the cross section area at section 1,1 and section 2,2 are same. So the cross section area of pipe is considered as pi by 4 d square. D is the diameter of pipe. Rho is density of fluid. Okay. Now let us apply the Bernoulli's equation at cross section 1,1 and at cross section 2,2 with consideration of head loss. So suppose at cross section 1,1 the total energy is pressure energy plus velocity energy plus potential energy. So it's a P1 by rho g plus V1 square by 2g plus Z1. P1 by rho g is pressure head, V1 square by 2 is kinetic head, and Z is potential head. At cross section 2,2 the total energy is pressure energy plus velocity energy plus potential energy plus HF means head loss in between cross section 1,1 and cross section 2,2 by fluid because of the friction between periphery of this pipe and fluid. Okay, so P2 by rho g plus V2 square by 2g plus Z2 plus head loss due to friction between fluid and pipe, that is HF. P2 by rho g is pressure head, V2 square by 2g is kinetic head, Z2 is potential head, and HF is head loss. But as you can see here in the figure, the pipe is horizontal, so potential energy on both sides get cancelled because Z1 is equal to Z2. You can take any reference bottom, you can take any reference bottom, and Z1 is equal to Z2. So the term Z1 and Z2 get cancelled on the both side. So the equation is reduces to P1 by rho g plus V1 square by 2g is equal to P2 by rho g plus V2 square by 2g plus HF. Take fluid steady. So if fluid steady, then velocity at cross section 1,1 and velocity at cross section 2,2 is same. So V1 is equal to V2. If V1 is equal to V2, then V1 square divided by V1 square divided by 2g is equal to V2 square divided by 2g is same. So V1 square divided by 2g, V1 square divided by 2g, this V1 square divided by 2g and V2 square divided by 2g get cancelled out on the both side. So equation is reduces to P1 by rho g is equal to P2 by rho g plus HF. Because V1 is equal to V2, so V1 square divided by 2g and V2 square divided by 2g get cancelled out on the both side. So this is the equation. Equation is reduces to P1 by rho g is equal to P2 by rho g plus HF. That's why HF is equal to P1 by rho g minus P2 by rho g. So we can write HF is equal to P1 minus P2 divided by rho g. So equation number 2. Sometime rho g is also write W. Now equating the horizontal forces on water between cross section 1 1 and cross section 2 2. See the figure number 1. This figure. So you can see here there are three horizontal force. One is F1, second is F2, and third is capital F, frictional resistance. This is the force F1, force F2, and frictional resistance. So with the direction you can say F1 is equal to F2 plus F. The direction of F1 is from left to right, and direction of F2 and F is from right to left. So we can write F1 is equal to F2 plus F. As we know, force is equal to pressure into area. So F1 is equal to P1 into A, F2 is equal to P2 into A, and this F is frictional resistance. So P1A minus P2A is equal to F. Take this P2A on the left hand side. So we can write P1A minus P2A is equal to F. That is why F is equal to, in bracket, P1 minus P2, take capital A outside the bracket. So we can get P1 minus P2 into A. Say equation number 3. Now, Froude's experiment have shown that the frictional resistance, this frictional resistance or this frictional resistance is directly proportional to three variable. Which three variable? One is weighted perimeter capital P, another is a length of pipe L, and average velocity, square of average velocity. In this case, the length of pipe is in between cross section 1 1 and cross section 2 2, which is capital L. So we can write frictional resistance F is directly proportional to weighted perimeter capital P, length of pipe L, and average velocity V. So V square of this average velocity. Now to remove this proportionality sign, I have to put one constant, which is F dash. So F is equal to F dash PL V square. So instead of F, you can put P1 minus P2 into A from equation number 3. See this equation number 3. F is equal to P1 minus P2 into A. So instead of this F, I put here P1 minus P2 into cross section area A, F dash PL V square as it is. Take this A on the right hand side. So P1 minus P2 is equal to F dash as it is, P divided by this cross section area A, L V square. Now divide by rho g on both sides. So P1 minus P2 divided by rho g, and F dash divided by rho g, P by A L V square as it is. P1 minus P2 by rho g is HF from equation number 2. This equation. P1 minus P2 divided by rho g is HF. So I can write P1 minus P2 by rho g is equal to HF. So instead of P1 minus P2 by rho g, I put here HF. F dash rho g as it is, P by A as it is, L V square as it is. Now take this P by A. P is a weighted perimeter, A is a cross section area. So weighted perimeter is pi d and cross section area is pi by 4 d square. So pi get cancelled, d 1d get cancelled. So I can get d by 4 in the denominator. So finally I can get 4 by d. So instead of P by A, I can put 4 by d in this equation. So the equation is HF F dash by rho g as it is. Instead of P by A, I can put 4 by d from this L V square. So HF is equal to F dash rho g, and this 4 L V square by d. Now F dash rho and g. F dash is constant from this. Rho is density of fluid, G is gravitational acceleration, so density and gravitational acceleration are again constant. So F dash by rho G is a constant, and one constant can be replaced by another constant. So I take a new constant F by 2 instead of F dash by rho G. So instead of F dash by rho G, I can put F by 2, a new constant. So my equation becomes HF is equal to F by 2 for L V square by D, and I am just rearranging the equation, and I get HF is equal to 4 FLV square by 2GD. The above equation is known as Darcy's Weisbach equation, which is used to uh, measure the head loss in flow through pipe. Small f, this small f is considered as coefficient of Darcy's friction factor. Okay, so this is the final equation. That equation is known as Darcy's Weisbach. Darcy and Weisbach both are physicists, and on the in the on their names, this equation is known as Darcy's Weisbach equation, and small f is considered as Darcy's friction factor, or sometimes it's referred as coefficient of Darcy's friction factor. Thank you.